Galaxies can be broadly classified into three main types: spiral, elliptical, and irregular. Spiral galaxies, like the Milky Way, have a disk structure with spiral arms. Elliptical galaxies are more football-shaped and lack distinct spiral arms. Irregular galaxies have irregular shapes and don't fit neatly into either category. Spiral galaxies. Spiral galaxies are characterized by a flat, rotating disk containing stars, gas, and dust. They have a prominent bulge at the center and spiral arms that extend outward from the bulge. The Milky Way is an example of a spiral galaxy. Spiral galaxies are further classified into two subtypes: barred spiral galaxies, which have a bar-shaped structure running through the center of the galaxy, and unbarred spiral galaxies, which lack this feature. Elliptical galaxies. Elliptical galaxies are generally smooth and featureless, with a spheroidal or ellipsoidal shape. They lack the distinctive spiral arms seen in spiral galaxies. Elliptical galaxies contain mostly older stars and have very little interstellar gas and dust. They range in size from small dwarf ellipticals to giant ellipticals that can be among the largest galaxies in the universe. Irregular galaxies. Irregular galaxies have chaotic and irregular shapes, lacking the well-defined structure of spiral and elliptical galaxies. They often contain large amounts of gas and dust and may show signs of recent star formation. Irregular galaxies are typically smaller and less massive than spiral and elliptical galaxies. Examples of irregular galaxies include the Large and Small Magellanic Clouds, which are satellite galaxies of the Milky Way. These are the main types of galaxies, but there are also more specific subclasses and variations within each type, based on factors such as size, shape, and internal structure. Galactic cannibalism, also known as galactic merger or galaxy collision, is a process in which one galaxy merges with and absorbs another galaxy due to gravitational interactions. This phenomenon occurs frequently in the universe, especially among galaxies within galaxy clusters. During a galactic merger, the gravitational forces between the galaxies cause them to come into close proximity, leading to distortions, tidal tails, and eventually the merging of their central bulges. Galactic cannibalism plays a significant role in shaping the evolution of galaxies, triggering bursts of star formation, redistributing gas and dust, and altering the structure and morphology of the merging galaxies. It is observed through telescopes and studied using computational simulations and theoretical models, providing valuable insights into the dynamics of galaxy interactions and their effects on galactic evolution. Galactic evolution refers to the process by which galaxies, such as our Milky Way, change and develop over time. This includes the formation of galaxies from the early universe, the evolution of their structure, composition, and the interactions between galaxies that can shape their trajectories. It involves complex astrophysical phenomena such as star formation, supernovae, galactic mergers, and the influence of dark matter and dark energy. One fascinating aspect of galactic evolution is how galaxies interact and influence each other's development over cosmic timescales. For instance, galactic collisions and mergers can trigger intense bursts of star formation, leading to the formation of new stars and the reshaping of galactic structures. These interactions not only impact the appearance and composition of galaxies, but also provide valuable insights into the underlying physics governing their evolution. The Milky Way is the galaxy that contains our solar system. It's a barred spiral galaxy, meaning it has a central bar-shaped structure surrounded by spiral arms. It's estimated to contain between 100 and 400 billion stars, including our Sun, and is about 100,000 light-years in diameter. Imagine the Milky Way as our cosmic home. It's a vast, swirling collection of stars, planets, gas, and dust, all held together by gravity. We live on one of the outer arms of this majestic spiral galaxy, surrounded by billions of other stars. Studying the Milky Way helps us understand the universe's structure and our place within it. One fascinating aspect of the Milky Way is its dark matter halo. Dark matter is an invisible substance that exerts gravitational pull but doesn't emit light or energy that we can detect with current technology. Scientists estimate that the Milky Way's dark matter halo is several times more massive than all the visible matter combined, shaping the galaxy's structure and influencing the motions of stars and gas within it. It's a mysterious and essential component of our cosmic neighborhood. Have you ever heard of dark matter? Imagine this galaxy is made up of stars, gas, dust, and planets. But did you know that all of this visible matter only makes up about 5% of the universe? This mysterious substance is called dark matter, and it makes up about 27% of the universe. Scientists can't see it, touch it, or even detect it directly. But we know it's there because of its gravitational effects on visible matter. Dark matter is believed to be the glue that holds galaxies together, and without it, the universe would look very different. Isn't that mind-blowing? So next time you look up at the night sky, just remember that there's a whole lot more out there than meets the eye. Black holes are these mysterious cosmic objects that have such strong gravitational pull that not even light can escape them. They basically devour everything in their path. Many galaxies, including the Milky Way, harbor supermassive black holes at their centers, which can be millions or even billions of times more massive than the Sun. Once you go past the event horizon, it's game over. You're stuck in a one-way ticket to the center of the black hole, known as the singularity. But don't worry. For us here on Earth, black holes are actually pretty fascinating to study. Scientists are still trying to unlock their many secrets. It's crazy to think about how something so powerful and mysterious can exist out there in the vastness of space. It really puts things into perspective, you know? So next time you look up at the night sky, remember that there are black holes thousands of light years away, silently lurking in the darkness. It's both terrifying and awe-inspiring. Redshift occurs when light emitted from an object moves away from an observer. This phenomenon is caused by the Doppler effect, where the wavelength of light is stretched as the emitting object moves away from the observer. As a result, the light is shifted towards the red end of the electromagnetic spectrum. In the context of astronomy, redshift is commonly observed in distant galaxies. The farther away a galaxy is from Earth, the faster it appears to be moving away from us due to the expansion of the universe. This causes the light from those galaxies to be redshifted, with the amount of redshift proportional to the galaxy's distance from Earth. Scientists use redshift measurements to determine the velocity of galaxies and other celestial objects, as well as to study the large-scale structure and evolution of the universe. Additionally, the cosmic microwave background radiation, which is the remnant radiation from the Big Bang, also exhibits redshift, providing crucial evidence for the expanding universe model. The Local Group is a gravitationally bound collection of galaxies located in the vicinity of the Milky Way. It contains over 54 known members, most of which are dwarf galaxies, along with the Milky Way and the Andromeda Galaxy, M31, which are the two largest members. The group spans about 10 million light-years across and is part of the larger Virgo supercluster. The dynamics within the Local Group are shaped by gravitational interactions among its members, leading to phenomena such as galaxy mergers and interactions. It serves as a valuable laboratory for studying galaxy formation, evolution, and dynamics. Studying the properties and interactions of galaxies within the Local Group provides valuable insights into broader astrophysical processes, such as star formation, chemical evolution, dark matter distribution, and the growth of supermassive black holes at galactic centers. It also offers a unique perspective on the cosmic web's hierarchical structure and the role of dark matter in shaping the universe's large-scale structure. Billions exist. There are billions of galaxies in the observable universe, each containing billions or even trillions of stars. Hubble's law is essentially an empirical observation that the universe is expanding uniformly in all directions. The farther away a galaxy is from us, the faster it appears to be moving away. This is often visualized with the analogy of dots on the surface of an expanding balloon. As the balloon inflates, all dots move away from each other, and the farther apart they are, the faster they move. The Hubble constant, denoted as h0, represents the current rate of expansion of the universe. It has units of kilometers per second per megaparsec, phi km s MPC, where a megaparsec is a unit of distance equal to about 3.26 million light-years. The value of the Hubble constant has been refined over time through various observational techniques and is crucial for understanding the age, size, and fate of the universe.